Welcome to the peaceful space of sleep-friendly science, where tonight we turn our gaze to the silent darkness between the stars and listen for a mysterious, fleeting whisper from deep space. These signals are called fast radio bursts, and they are one of the greatest unsolved puzzles in modern astronomy. For a thousandth of a second, something in the distant universe unleashes a torrent of energy. What could it be? Let your mind drift as we explore the suspects, from dying stars to alien beacons. Now settle in, take a deep breath, and let the soft sounds guide you as we begin tonight's journey into the unknown. Section 1. A sudden shout. Imagine, if you will, the great deep quiet of the cosmos. Not the absence of sound, for space is filled with a different kind of song. There is the gentle, persistent hiss of the cosmic microwave background, the faint thermal afterglow of creation's first great cry. There is the steady lighthouse pulse of ancient pulsars, spinning with the rhythm so precise they are nature's most perfect clocks. There is the slow, majestic hum of galaxies turning, a symphony on a scale so vast that a single note lasts 100 million years. For eons, this has been the steady, predictable music of the universe. A music of immense power but of immense patience. Now let us journey to a quiet valley in eastern Australia, to the Parkes Observatory. Here a great metal dish, 64 meters across, stands like a giant sensitive ear, cupped towards the heavens. Its purpose is not to see the light of the stars, but to listen to their invisible radio whispers. Day and night, it scans the sky, patiently gathering these faint signals, translating the ancient music of the cosmos into streams of data, rivers of numbers flowing into the memory of a computer. This is a quiet act of faith. The astronomers who guide this great ear are listening for the subtle variations in this cosmic song. They are searching for the known rhythms, the familiar signatures of spinning neutron stars and distant quasars. The data flows in a gentle and unending stream, mostly a soft static hiss, the sound of the universe simply being itself. And then one day in 2007, as an astronomer named Duncan Lorimer and his student David Narkevic were sifting through years of this old, archived data, something impossible appeared. For a fleeting, almost imperceptible moment in the data from 2001, the cosmic quiet was broken. It was not a slow crescendo, not a gradual change in the music. It was a sudden, sharp, and astonishingly loud shout. Imagine listening to the gentle hum of a quiet room, and for less than the time it takes to blink, a single deafening trumpet note sounds, and then vanishes as if it were never there. This is what the great ear at Parkes had heard. It was a burst of radio waves that lasted for less than 5 milliseconds, a tiny fraction of a second. But in that infinitesimal slice of time, it shone with a terrifying brilliance. The astronomers calculated the energy of this single fleeting pulse, and the answer was staggering. In that thousandth of a second, the source of this signal had released more energy than our own sun, the fiery heart of our solar system, releases in an entire day. And then it was gone. Absolute silence. The gentle, cosmic hiss returned, as if nothing had happened. What do you do with such a ghost in the machine? The first, most logical reaction is disbelief. It must be a mistake. A glitch in the telescope's electronics. A stray signal from a passing satellite. Perhaps even, as was later found to be the cause of other strange signals, a scientist opening a microwave oven in the observatory's kitchen at just the wrong moment. The astronomers were detectives presented with a single impossible clue. They spent months trying to debunk their own discovery. They searched for any conceivable source of interference here on Earth. They scoured the data for a flaw, for a sign that the great machine had simply hiccuped. They found nothing. The signal was clean. It was sharp. And it had all the hallmarks of something that had traveled a very, very long way. The ghost refused to be exorcised. So they kept looking, sifting through more of the old data, searching for another echo of this impossible shout. And slowly, painstakingly, they found others. Faint, millisecond-long bursts, from different points in the sky, all sharing the same perplexing characteristics. They were not a mistake. They were real. A new cosmic mystery had been born. They gave it a simple descriptive name, a fast radio burst, or FRB. It was a name that captured the two things they knew for sure: it was fast and it was in the radio spectrum. Everything else, what it was, where it was coming from, and what could possibly create such an astonishing burst of power, was a complete and utter unknown. The universe, in its deep and ancient slumber, had suddenly shouted in its sleep. And the faint echo of that shout, caught by our patient listening ear on Earth, had just opened a new and profound chapter in our exploration of the cosmos. Section 2. The Cosmic Fingerprint. That first impossible shout from the depths of space was more than just a sudden noise. It was a message, and like a letter sent from a distant country, it carried upon it the subtle marks of its long and arduous journey. The astronomers who found it were detectives, and their first and most profound clue was not in the loudness of the shout, but in its timing. It carried a unique and beautiful cosmic fingerprint. To understand this fingerprint, you must first understand the nature of the signal itself. This burst of radio waves was not a single monolithic entity. It is more helpful to imagine it as a single brilliant chord, struck on a cosmic piano. It was composed of many different notes or frequencies, all played at the exact same instant, at the source of the burst millions or billions of light years away. There were high energetic notes and low, more mellow notes, all beginning their immense journey together. Now, imagine the space between the stars and between the galaxies. We often think of it as a perfect, absolute vacuum and emptiness of pure nothing. But this is not quite true. The vast chasms of the cosmos are filled with a thin, almost imperceptible mist. It is a tenuous, ghostly sea of charged particles, free electrons and protons, the leftover dust of ancient stars, and the primordial gas of the universe itself. For a single traveler, this mist is so thin as to be non-existent. But for a messenger on a journey of 1 billion years, this mist becomes a palpable presence. It is a headwind, and this cosmic headwind has a peculiar effect. It does not treat all travelers equally. It has a greater effect on the lower notes of our cosmic chord than it does on the high notes. Imagine the different notes as a procession of travelers setting out on a great pilgrimage. The high-frequency notes are like swift, nimble runners, barely slowed by the thin ethereal fog. But the low-frequency notes are like walkers in heavy robes. The ghostly mist clings to them, slowing their progress just a tiny, tiny bit more. Over a short distance, this difference is unnoticeable. But the journey of a fast radio burst is not a short one. It is a pilgrimage across millions, even billions of light years. Over these unimaginable distances, the tiny cumulative drag of the intergalactic medium adds up. The swift, high-frequency runners begin to pull far ahead of their slower, low-frequency companions. The single perfect chord that started its journey all at once becomes stretched out, dispersed in time. And so when this ancient signal finally arrives at our listening ear on Earth, it does not arrive all at once. The highest, fastest notes of the chord arrive first. Then, a few milliseconds later, the lower, slightly slower notes come trailing in behind. The single instantaneous shout has been smeared into a characteristic downward sweeping whistle, like the sound of a cosmic bird diving through the sky. This smearing, this time delay between the arrival of the high and low frequencies, is what astronomers call the dispersion measure. It is the fingerprint of the journey. By measuring the precise amount of this delay, astronomers can calculate exactly how much of that ghostly intergalactic mist the signal has traveled through. It is like looking at a postcard and from the number of postmarks and the wear on its edges, being able to tell just how far it has come. And the fingerprint on that first fast radio burst told an astonishing story. The delay was enormous. The signal was so profoundly smeared by its journey that it must have traveled through far more of that thin, cosmic fog than our own Milky Way galaxy could possibly contain. It had not just crossed our galaxy. It had crossed the void between the galaxies. This was the clue that transformed the mystery. This was not a local event. This was not some strange type of star within our own cosmic neighborhood. This was a true message from the deep, a shout from a distant unknown galaxy, sent on its way long before our own human species ever walked the Earth. It had traveled through the dark, empty spaces for hundreds of millions or even billions of years, carrying its story, its fingerprint, all the way to our quiet little world. The mystery was no longer just about what could create such a powerful burst. It was about what could create such a burst in the far, far reaches of the ancient universe. Section 3: Chasing a Ghost. The cosmic fingerprint of the dispersion measure was a revelation. It told you, the cosmic detective, that these shouts were not coming from next door, but from across the street, in a neighborhood of stars billions of light years away. You knew the distance to the source, but you had a new and even more profound problem. You knew how far away the shout was, but you had no idea which house it came from. You were chasing a ghost. Imagine seeing a flash of lightning on a completely overcast night. You see the entire sky light up for a fraction of a second. A moment later you hear the distant rolling thunder, and from the delay, you know the storm is many miles away. But where exactly did the lightning strike? Behind which cloud? Above which unseen treetop? The flash was too brief and your view too broad to tell. This was the monumental challenge facing the first FRB hunters. A single-dish radio telescope, like the Great Ear at Parkes, has a wide and benevolent gaze. It listens to a relatively large patch of sky at once. When a millisecond-long burst flashes through its field of view, the telescope registers the event with perfect clarity. But the pixel of its vision is blurry. The data can tell you that the burst came from a certain broad region of the sky, a region that might contain thousands of faint, distant galaxies. The cosmic address was still maddeningly vague. It was like knowing a letter came from Paris, but having no street name or number. For years, this was the state of the art. Astronomers would catch these lonely, fleeting signals, these cosmic maydays, and they could add them to a growing collection. It was like a gallery of beautiful but anonymous portraits. For each one you knew its story, how long it had traveled, the cosmic mist it had passed through. But the face of the source, the galaxy it called home, remained a frustrating, blurry mystery. And because each burst seemed to be a one-time event, there was no way to prepare. By the time you detected a burst and could point other, more powerful telescopes to that patch of sky, the ghost was gone, perhaps forever. And then, in 2012, everything changed. A new burst was detected by the Arecibo Observatory, a colossal dish nestled in the hills of Puerto Rico. The signal, catalogued as FRB 121102, had all the classic hallmarks. It was fast. It was powerful. And its dispersion measure told a familiar story of an immense intergalactic journey. But then, something unprecedented happened. It happened again. From that same tiny patch of sky, another burst was detected. And another. And another. The ghost was no longer just a ghost. It was a haunting. The lightning was striking the same place over and over. This was the breakthrough the astronomers had been praying for. A repeater. The game had changed from one of passive, patient listening to one of active, targeted hunting. Now they knew exactly where to look. They knew that if they stared at this one unremarkable patch of sky long enough, the source would speak again. So they marshaled the world's greatest telescopes. They pointed the Very Large Array in New Mexico, a vast armada of 27 radio dishes that can work together as a single incredibly sharp eye at this one spot. They waited. And as the repeater obliged, sending out more of its strange staccato shouts, the VLA used the power of interferometry to do what a single dish never could. By combining the signals from all its separate dishes, it could triangulate the source with breathtaking precision. It was like using two ears to pinpoint the location of a faint sound, but on a cosmic scale. The blurry pixel sharpened into a single crystalline point. And when they aimed the Hubble Space Telescope and other powerful optical instruments at that exact point, they found it. They found the house the shout was coming from. It was not a large, majestic spiral galaxy like our own Milky Way. It was something much smaller, much fainter, and much more exotic. The first precisely located fast radio burst was coming from a tiny dwarf galaxy, more than 3 billion light-years from Earth. And it wasn't just any dwarf galaxy. It was a frantic little city of stars, a place undergoing a ferocious burst of new star formation. It was a violent and beautiful cradle, a place of stellar youth and turmoil, filled with the kind of massive, short-lived stars that die in spectacular explosions. The first piece of the puzzle about the environment of an FRB had just been snapped into place. The ghost had a home, and its neighborhood was a place of fire and chaos. Section 4. Cataclysms in the Dark. The ghost now has a home. You have traced the repeating shout of FRB 121102 across 3 billion light-years of cold, dark space to its source. A tiny, turbulent city of stars, ablaze with the fire of new creation. The address is known, and this address is a vital clue. It is a violent neighborhood, a place where massive, short-lived stars are born and die in spectacular fashion. So, you, the cosmic detective, must now ask the most logical question. If the shout is coming from a violent place, perhaps the shout itself is an act of violence? The sheer, ungodly energy of the burst, more than our sun puts out in a day, all released in a millisecond, screams of a cataclysm. It feels less like a signal and more like a scream, a death cry. So let us turn our investigation to the usual suspects for cosmic violence, the great and terrifying cataclysms that tear through the dark. Our first suspect is the most famous of all celestial fireworks, the supernova. Imagine a star many times more massive than our sun. For millions of years it has burned with a brilliant, majestic light, a beacon in its galaxy. But its life is short and its end is preordained. When it exhausts its nuclear fuel, its core collapses under its own immense weight, and then rebounds in the single most powerful explosion the universe can produce. This is a supernova. For a few brief weeks, this single dying star can outshine its entire home galaxy of 100 billion stars. Surely, an event of such unimaginable power could produce a millisecond radio flash. And the neighborhood fits perfectly. A star-forming galaxy is a nursery for the very massive stars that are destined to go supernova. The suspect was in the right place at the right time. But there is a fatal flaw in this beautiful theory. A ghost cannot die twice. A supernova is the final operatic aria of a star. It is an act of ultimate, irreversible self-destruction. The star explodes and then it is gone, its contents scattered to the cosmic winds to one day form new stars and new worlds. But FRB 121102, our ghost, repeated. It shouted, and then it shouted again and again from the exact same spot in the sky. A supernova cannot do this. And even for the FRBs that we have only seen once, the theory struggles. A supernova leaves behind a vast, expanding cloud of hot gas that glows in the radio spectrum for weeks, months, even years after the explosion. But when we look at the locations of these single FRBs, we do not find this telltale, fading afterglow. The scream is there, but the body is missing. The portrait fits, but the alibi is flawed. The supernova, our prime suspect, must be let go. So we turn to an even more exotic class of cataclysm. Let us consider the final violent embrace of two dead stars. Imagine two neutron stars, the collapsed, city-sized corpses of suns that have been locked in a cosmic waltz for eons, orbiting each other in a slow, graceful spiral. Or imagine two black holes, points of infinite density, engaged in the same deadly dance. As they orbit, they radiate away energy in the form of ripples in spacetime itself, and their dance quickens. They draw closer and closer, spinning faster and faster, until they finally merge in a collision of unimaginable violence, an event that shakes the very fabric of reality. Here surely is an event with enough power. The energy released in such a merger is colossal, dwarfing even a supernova. Could a flash of radio waves be part of this cosmic wreckage? It is a tantalizing idea. But again, the repeater stands as a silent witness against it. These mergers, like supernovae, are final acts. The two stars become one. The dance is over. There is no possibility of an encore performance. For the repeating FRBs, this suspect is an impossibility. And for the single bursts, the models of these mergers predict a different kind of signal, a different kind of cryoburst of gamma rays, a flash of visible light, a cascade of gravitational waves. A powerful focus beam of radio waves is not their expected signature. Their voice is different. And so, with a sense of deepening mystery, we must dismiss these suspects as well. You are left with a profound and beautiful paradox. The shout has the energy of a cataclysm, the power of a dying star. But the source does not die. It persists. It lives to shout again. This means our culprit cannot be a one-time event of self-destruction. It must be a long-lived object. A stable, enduring thing that has somehow harnessed the ability to unleash explosions of energy that rival the death of a sun, and to do so repeatedly. What kind of creature can shout with the voice of a dying star, and yet live to shout again? The search has now shifted. We are no longer looking for a murderer. We are looking for a monster. Section 5. The Magnetar Hypothesis. You stand now in the midst of a profound cosmic puzzle. The evidence has led you to a startling conclusion. You seek a long-lived, enduring celestial object that can somehow produce repeated bursts of energy on a cataclysmic scale. The usual suspects of cosmic violence have been dismissed. You need a new one, a creature of endurance and of fury. And so, let us now turn our investigation to what is, for many astronomers, the prime suspect in this grand mystery. It is one of the most extreme and exotic objects the universe has ever conceived. It is a magnetar. To understand a magnetar, we must first return to the death of a massive star. We have seen that a supernova is the star's final glorious explosion. But what is left behind in its wake? If the star is massive enough, its core collapses into a black hole, a point of no return. But if the star is in a certain sweet spot of mass, something else is born. The crushing force of the collapse is so immense that it overcomes the very structure of matter itself. Protons and electrons are squeezed together with such violence that they merge, becoming neutrons. The entire collapsing core, a mass greater than our sun, is compressed into a sphere no larger than a city. This is a neutron star. It is the ghost of a sun. It is a single gigantic atomic nucleus, a ball of pure neutronium so dense that a single teaspoon of its substance would weigh as much as a mountain range. It is an object of profound strangeness, a place where the laws of physics are pushed to their absolute limit. But in the violent chaos of its birth, some of these neutron stars are born with a special terrifying inheritance. As the massive core collapses, it spins faster and faster, like an ice skater pulling in their arms. And as it spins, it amplifies the magnetic field of the original star to an unimaginable degree. Most neutron stars have powerful magnetic fields. But a tiny fraction of them, perhaps 1 in 1,000, become something else entirely. They become a screaming magnetic dynamo. They become a magnetar. A magnetar is not just a neutron star. It is a neutron star with a demon trapped inside. The demon is its magnetic field, the most powerful magnetic field in the known universe. To say it is strong is a profound understatement. It is 100 trillion times stronger than a refrigerator magnet. It is 1,000 times stronger than the field of an ordinary neutron star. It is a force so powerful that it could strip the data from every credit card on Earth from halfway to the moon. It is a field so intense that it distorts the very shape of the atoms on its surface and heats the star's crust to millions of degrees. This immense magnetic field is the magnetar's great reservoir of energy. And it is not a stable, peaceful thing. The field lines are twisted into immense, complex braids of pure force, like trillions of rubber bands, stretched to the breaking point. The magnetar is a creature in a constant state of visceral, internal strain. The solid crust of the neutron star is locked in a battle with the shifting, writhing magnetic field beneath it. And here in this tension we find a plausible engine for our mysterious shouts. Imagine for a moment that the immense magnetic field deep within the star suddenly shifts, reconfiguring itself into a slightly more stable arrangement. This shift would send a seismic wave of pure energy shuddering through the star's superdense crust. The entire city-sized object would ring like a colossal bell, an event we call a starquake. This violent convulsion could launch a fireball of particles and energy out into space, a sudden sharp cry. Or imagine another possibility. The twisted braids of magnetic field lines that extend out from the star into its surrounding cloud of plasma become too tangled, too stressed. And then suddenly they snap. Like a frayed rope giving way, the magnetic field lines reconfigure themselves into a simpler, lower energy state. In that single instantaneous snap, a colossal amount of stored magnetic energy is released into the surrounding plasma. This sudden injection of energy could generate a powerful, coherent shockwave of radio waves, a beam of light, so intense it could be seen across galaxies. It would be a cosmic lightning bolt, born from the snapping of a magnetic braid. This is the magnetar hypothesis, and it is beautiful because it fits the evidence so perfectly. A magnetar is a long-lived object. It can persist for tens of thousands of years, easily explaining the repeaters. It possesses an energy source powerful enough to generate the FRBSIT's colossal magnetic field. And its behavior, the sudden, unpredictable violence of a starquake or a snapping field line, perfectly matches the fleeting millisecond timescale of the bursts. You, the cosmic detective, now have a suspect whose portrait seems to match the crime in every detail. But a portrait is not a confession. You need more. You need a smoking gun. Section 6. The Galactic Smoking Gun. For years, the magnetar remained a beautiful but distant suspect. It was a perfect portrait of a culprit, a theoretical sketch that matched the criminal profile in every way. But all the known FRBs were millions, even billions of light-years away. Confirming the link was like trying to match a fingerprint from a grainy photograph taken from miles away. The evidence was circumstantial. What you, the cosmic detective, desperately needed was an encounter with the suspect up close. You needed a confession. You needed a smoking gun. But what if the suspect wasn't across the ocean? What if a magnetar in our own cosmic backyard, our own Milky Way galaxy, decided to act up? The galaxy is home to a few dozen known magnetars, quiet monsters sleeping in our midst. For years, they had been watched, their occasional gentle flares of X-rays and gamma rays catalogued and studied. But they had never been caught shouting in the radio spectrum, not like their distant cousins. And then, on April 28, 2020, the universe decided to provide the missing clue. Let us travel now to two different places on Earth. First, to Canada, to a strange-looking telescope called CHIME. It doesn't have a big steerable dish. It looks more like a collection of four giant metal half-pipes, like a skateboard park for titans. CHIME is a revolutionary new ear, designed specifically to hunt for FRBs. It has no moving parts. It simply stares at the vast swathe of sky that passes overhead as the Earth turns, its powerful computers sifting through the data in real time, listening with an unblinking gaze. At the same time, in the United States, a smaller network of radio antennas called STARE-2 was also listening, a simple but effective watchdog scanning the local cosmos. On that April morning, something extraordinary happened. The magnetar known as SGR 1935+2154, a well-known object in our own galaxy about 30,000 light-years away, let out a violent shudder. High-energy space telescopes like Europe's integral satellite, which are designed to watch for gamma rays and X-rays, saw the magnetar flare up, a familiar if powerful tantrum. But at the very same instant, CHIME and STARE-2 were hit with a tidal wave of radio energy. This wasn't a faint whisper from across the universe. This was a shout directly into the microphone. The signal was so titanically, overwhelmingly powerful that it temporarily saturated Chime's sensitive detectors. It was without question the loudest radio burst ever recorded from within our galaxy, and it had the perfect fingerprint. When astronomers analyzed the signal, they saw the classic downward sweeping whistle of dispersion. But the delay was small. The amount of smearing was modest. It told the story of a signal that had traveled not across the intergalactic void, but merely across the familiar misty plains of our own Milky Way. This was the moment, the smoking gun. In a single beautiful, unambiguous event, an object that we knew was a magnetar was caught red-handed, producing a burst of radio waves that looked, for all the world, like a fast radio burst. The high-energy flare and the radio burst were a simultaneous confession, a single event seen in two different kinds of light, originating from the same celestial culprit. The case was, in a sense, closed. The long-debated link between magnetars and FRBs was no longer a theory. It was an observed fact. The source of the cosmic shouts now had a name and a face, and it was a monster just as suspected. But like any good mystery, the solving of one puzzle only revealed deeper, more subtle ones. The burst from our galactic magnetar was powerful, astoundingly so for a local event. But when astronomers did the math, they found that it fell just short of the colossal energies of its extragalactic cousins. The shout from across the street was deafening, but the whispers from across the continent were, in their origin, even more powerful. It seemed that our local magnetar had produced a powerful but not record-breaking burst. Was it just having a quiet day? Or are the extragalactic FRBs produced by a different, even more extreme mechanism, or perhaps by younger, more ferocious magnetars than the ones that sleep in our own more ancient galaxy? The smoking gun had been found. The culprit had been identified. But the detectives' work was far from over. You now knew who was shouting. But you still didn't fully understand why they sometimes whispered, why they sometimes screamed, and most perplexingly of all, why some of them seemed to be shouting on a schedule. Section 7. The Mysterious Repeaters. The discovery of a fast radio burst from a magnetar in our own galaxy was a watershed moment. It felt like the final satisfying chapter of a great detective story. The culprit had been caught, the central mystery solved. But the universe is rarely so simple. And just as this sense of closure was settling in, a different set of clues began to whisper of a deeper and more perplexing puzzle. This is the mystery of the repeaters, and their strange, unexpected habits. We have already met the first and most famous of these repeaters, FRB 121102, the ghost that learned to haunt. Its steady, repeating nature was the key that allowed us to find its home galaxy. Since then, dozens more of these repeating sources have been discovered, a special class of FRB that refuses to perform just once. But as we have watched them, a new layer of complexity has emerged. Their repetition is not always random. Some of them have a rhythm. Let us return to our little dwarf galaxy 3 billion light-years away, the home of FRB 121102. As astronomers continued to monitor this source over years, they noticed a strange pattern. The source was not always active. It would switch on, producing a flurry of bursts over a period of about 90 days. And then, just as suddenly, it would fall completely silent for a period of 67 days. And then, like clockwork, it would switch back on. A 90-day window of shouting, followed by a 67-day window of silence. A repeating cycle of 157 days. What could possibly account for such a slow, deliberate, and predictable pattern? A single magnetar, acting alone, should not behave this way. A starquake or a snapping magnetic field line is a chaotic, unpredictable event, like an earthquake on our own planet. We cannot predict them. They should not follow a schedule. The magnetar itself spins on its axis in a matter of seconds. Its internal processes should happen on timescales of milliseconds or, at most, hours. A slow, stately rhythm of months seems to defy the nature of the object itself. The mystery deepened with the discovery of another repeating source, much closer to home, catalogued as FRB 180916. This one also had a rhythm, but a much faster one. It would be active for a window of about 4 days and then silent for 12. A perfect repeating cycle of 16 days. This kind of long-term, periodic behavior points to something else. It whispers of a system. It suggests that our magnetar may not be alone. Perhaps our shouting monster is not an isolated hermit, but is part of a cosmic dance. Imagine our magnetar locked in an orbit with another star, perhaps a massive bright companion. The two stars waltz around each other, a celestial couple in a long, slow dance. The magnetar may be constantly producing bursts, constantly shouting into the void. But we can only hear it when it is in a certain part of its orbit. For part of its dance, its companion star might be in the way. Its thick stellar wind, a constant stream of particles blowing off its surface, acting as a dense fog that absorbs or scatters the radio waves. We can only see the lighthouse when it is not eclipsed by the island it sits beside. This orbital eclipse model could neatly explain the periodic windows of activity. The 16-day cycle of one repeater, or the 157-day cycle of the other, could simply be the length of its year, the time it takes to complete one orbit around its partner. Or perhaps the companion isn't just a passive obstruction. Perhaps it is an active participant. What if the magnetar's bursts are not entirely self-generated, but are triggered by its companion? As the magnetar plows through the dense stellar wind of its partner star, this interaction could provide the extra energy, the final nudge needed to cause its tangled magnetic field to snap and release a burst. It would only shout when it passed through the densest part of its partner's breath. Another possibility is even more majestic. A neutron star, a magnetar included, often does not spin perfectly. Its axis of rotation may be tilted, causing it to wobble like a slightly off-kilter top. This wobble, called precession, could be very slow, taking weeks or months to complete one cycle. If the magnetar's radio bursts are fired out in a narrow searchlight-like beam, then this slow wobble could mean that the beam only sweeps across our line of sight during a specific part of its precessional cycle. We don't see the lighthouse because it is blocked. We see it because its slowly turning lamp has finally pointed in our direction. Each of these theories is beautiful and compelling, but they all add a new layer of complexity to our picture. They require us to imagine not just a single extraordinary object, but an entire stable system, arranged in just the right way. It means that to solve the puzzle of these strange, clockwork repeaters, we must become not just physicists, but celestial choreographers, trying to understand the steps of a dance happening in a ballroom 3 billion light-years away. The solo performance has become an intricate ballet, and its silent music is a rhythm of months and days, a rhythm we are only just beginning to learn. Section 8. A tool to weigh the universe. For our entire journey so far, we have treated these sudden shouts from the void as the mystery itself. We have been cosmic detectives, chasing a ghost, identifying a monstrous culprit, and trying to understand the intricate choreography of its strange, repeating dances. The fast radio burst has been the puzzle we are trying to solve. But what if we have been looking at this all wrong? What if the burst is not the destination of our search, but the flashlight that illuminates the path? Let us now, for a moment, shift our perspective and see these cosmic whispers not as a mystery, but as a magnificent and powerful new tool. Let us return to the cosmic fingerprint, the beautiful downward sweeping whistle of the dispersion measure. We know that this smearing of the signal is caused by its long journey through the thin, ghostly sea of charged particles that fills the void between the galaxies. We have used this fingerprint as a clever way to estimate the distance to the burst, like a postmark on a letter. But its true gift is far more profound than that. The dispersion measure is not just a measure of distance. It is a direct and precise accounting of the stuff the signal has traveled through. Imagine the FRB as a pure white beam of light sent shining through a vast, dark, and mostly invisible fog. The fog is the intergalactic medium, the tenuous web of gas and plasma that stretches between the galaxies, the great unseen scaffolding upon which the universe is built. For decades, astronomers have faced a profound puzzle known as the missing baryon problem. When they added up all the normal visible matter in the universe, all the stars, the galaxies, the gas clouds, they could see their census of the cosmos was coming up short. The universe felt lighter than their theories predicted it should be. They knew there had to be more normal matter out there, hiding in the dark, but it was too thin, too diffuse, and too dark to detect with their telescopes. And here, in this beautiful convergence, two great mysteries meet. The fast radio burst, this enigmatic shout from an unknown source, has become the key to finding this missing matter. The signal is not just a message, it is a core sample. It carries within its stretched-out form a precise accounting of every single free electron it encountered on its billion-year pilgrimage. Think of it this way. With every FRB we detect, we are firing a cosmic probe along a single straight line through the universe. And that probe comes back with a perfect record of the density of the invisible medium along that one specific path. With one FRB we have one line drawn through the dark. We know how much stuff is between here and that one distant galaxy. With 100 FRBs coming from all different directions and all different distances, we begin to sketch a map. With thousands, which new telescopes like CHIME are now detecting, the invisible scaffolding of the universe begins to resolve before our eyes. We are, for the first time, able to see the unseen. The data from these cosmic messengers allows us to build a three-dimensional map of the intergalactic medium. We can begin to see its structure. We can find the great, dense filaments of this cosmic web, the superhighways of gas that connect clusters of galaxies. And we can find the vast, empty regions in between, the great cosmic voids where the ghostly fog is thinnest. We are making the invisible visible. We are tracing the skeleton of the cosmos. And in doing so, we have solved the old mystery. The missing matter wasn't missing at all. It was exactly where the theories predicted it would be, hiding in plain sight in this vast, diffuse web. And the tool we are using to finally see it, to finally complete our census and, in a very real sense, to weigh the universe, is the echo of a monster's shout from a distant galaxy. What a beautiful and profound irony! A phenomenon that began as a complete and baffling puzzle has become one of our most powerful instruments for cosmology. The mystery has become the key. The ghost we were chasing has turned around and offered to be our guide, illuminating the dark, unseen corners of the universe with its own fleeting, brilliant light. The universe, it seems, has the habit of hiding the answer to one great question inside the enigma of another. Section 9. An extraordinary whisper. And so, our journey has brought us to a place of beautiful, rational comfort. We have a culprit, the magnetar, a celestial monster of almost unimaginable power. We have a motive, the violent, unpredictable snapping and shuddering of its colossal magnetic field. We even have a smoking gun, a confession from a magnetar in our own galactic neighborhood. We have even found a way to turn this cosmic puzzle into a powerful tool, a flashlight to illuminate the dark and weigh the unseen matter of the universe. The case, it seems, is solved. We can close the book, satisfied that we have found a natural, if astonishing, explanation for these sudden shouts in the dark. And yet, in the quietest corners of this grand investigation, after all the logical suspects have been examined and the evidence has been weighed, there is another whisper, a faint, tantalizing, and perhaps foolish thought that refuses to be completely silenced. It is the most extraordinary and the most human of all possibilities. It is the thought that these signals might not be the scream of a dying star, or the tantrum of a magnetic monster. It is the thought that they might be a message. Let us, for a moment, gently and without judgment, allow ourselves to explore this extraordinary whisper. Let us play the role of a different kind of detective, one who is looking not for a natural culprit, but for an intelligent one. What is the evidence that might lead us to such a wild conclusion? First, there is the sheer efficiency of the signal. The burst is almost entirely concentrated into a narrow band of radio frequencies. It is a remarkably clean signal. Natural cataclysms tend to be messy. A supernova, for example, explodes across the entire electromagnetic spectrum, releasing a chaotic flood of visible light, X-rays, gamma rays, and a broad smear of radio waves. But an FRB is focused. It is precise. It feels to some less like a natural explosion and more like a perfectly engineered broadcast, a signal designed to be as powerful and as noticeable as possible, a cosmic shout designed to be heard across the ocean of the void. Then there is its brevity, the millisecond duration. It is so short, so sharp, so distinct. It feels like a digital pulse, not a lingering echo. And within some of the brighter bursts, astronomers have found even finer, more complex structures, subbursts that drift downward in frequency, hints of a complex emission mechanism that is not yet understood. It does not feel like the simple messy clang of a cosmic car crash. It feels, to the hopeful ear, like it has structure. And most compelling of all, there are the repeaters, especially those with their strange, clockwork regularity. A natural, chaotic process should not follow a schedule. But a beacon does. A lighthouse flashes with a predictable rhythm to guide ships through the dark. Could the 16-day cycle of one repeater, or the 157-day cycle of another, be the deliberate repeating signal of a cosmic lighthouse, sweeping its beam across the galaxy? Or perhaps a powerful transmission from a vast, orbiting planetary radar system, its beam sweeping past our line of sight with every year of its planet's journey? It is a beautiful and awe-inspiring thought. But here science, in its quiet and patient wisdom, asks us to pause. The great astronomer Carl Sagan gave us a beautiful and humble guide for moments like these. Extraordinary claims require extraordinary evidence. And while the questions raised by FRBs are extraordinary, the evidence for an artificial origin is, as yet, profoundly lacking. The principle of Occam's razor gently reminds us that we should not invent a complex new explanation when a simpler, more natural one fits the facts. And the magnetar hypothesis, while exotic, is a natural explanation. We know magnetars exist. We have seen them produce an FRB. The physics, while extreme, is plausible. To invoke a vast, alien intelligence is to add a layer of immense, unproven complexity. And there is the energy problem. The power required to generate these bursts is so colossal that it is difficult to imagine even a highly advanced civilization wanting to, or being able to, expend such a godlike amount of energy on a simple beacon. What message could possibly be so important as to require the energy of a sun to transmit? And finally, the signals themselves, for all their structure, contain no obvious, discernible message. There is no repeating pattern of prime numbers, no hello world encoded in the pulses. They look, to the objective eye, more like the product of extreme and exotic physics than the product of an extreme and exotic intelligence. To search for a message in the static is perhaps one of the most human things we can do. It is a reflection of a deep and beautiful hope within our own hearts, a desire not to be alone in this vast, dark, and silent universe. And science does not discount the possibility. It simply asks for proof. For now, science holds the powerful natural explanation of the magnetar in one hand. And in the other, it holds a quiet, open space for wonder, for further observation, and for the gentle, persistent, and extraordinary whisper that asks, what if? Section 10. The Symphony of Silence. And so the book of this great cosmic mystery lies open before you. We have followed the clues together, you and I, on a journey across billions of years of silent, empty space. We began with a single, impossible shout in the dark, a whisper of energy so fleeting it was almost missed. We learned to read its cosmic fingerprint, a message written in the smearing of light, which told us of its immense intergalactic pilgrimage. We chased its ghost across the heavens, and with the help of a source that refused to be silent, we finally found its home, a turbulent, star-forming city in the distant universe. We have stood before the prime suspect, the magnetar, a monster of physics, a dead star wrapped in a demonic magnetic field. And we have heard its confession in the form of a burst in our own galactic home. We have seen how these strange whispers can become a tool, a flashlight to weigh the universe and find its missing hidden matter. We have even allowed ourselves to entertain the most extraordinary whisper of all, the hope that we might be listening to a message. And yet the book is not quite closed. The final page has not yet been written. The mystery for all our progress endures. Why do some sources repeat with such clockwork precision? Why were the whispers from deep space so much more powerful than the shout from our own backyard? The magnetar is the beginning of the answer, but it is not yet the entire story. And perhaps this is the most beautiful truth of all. The purpose of our journey was never just to find a simple answer. It was to learn how to listen. Imagine yourself now sitting in a vast, dark, and silent concert hall. The universe is the musician on the stage. For most of its performance, it plays a soft, gentle ambient piece, the hum of the background radiation, the slow rhythm of the turning galaxies. This is the music of silence. It is beautiful, but it is predictable. And then, for a thousandth of a second, the musician strikes a single brilliant, deafening chord on the piano, and then falls silent again. That is a fast radio burst. Our first instinct is to ask, why did the musician play that chord? But perhaps a deeper question is simply, what does it feel like to be in a hall where such a thing is possible? To be an audience to a performance of such infinite dynamic range? The universe is not a silent film. It is a symphony. And it is a symphony defined as much by its silence as by its notes. What fills the silence between the bursts? It is the quiet, patient work of gravity. It is the slow cooking of new stars in their dusty nebulae. It is the silent, graceful waltz of the galaxies. And it is the humble, persistent act of our own listening. The silence is the canvas upon which these sudden, brilliant flashes of inspiration are painted. And the fact that we are here at all, with our strange metal ears cupped to the heavens, ready to catch these fleeting notes, is perhaps the greatest miracle in the entire performance. So as you drift now, let the grand mystery of the FRBs resolve into a simple sense of peace. You do not need to know all the answers. All that is asked of you is to appreciate the music. The universe is expressing itself, in its own wild, unpredictable, and powerful way. Each new signal is not a problem to be solved, but a new note in the ever-unfolding symphony. And we, in our brief and precious moment of consciousness, are the lucky ones. We are the audience. We get to hear the song. Let the vastness of that cosmic auditorium now become the quiet comfort of your own room. The great symphony of space fades into the gentle, rhythmic music of your own breathing. The search for a distant whisper becomes the simple act of listening to the beat of your own heart. You are a part of this universe, made of the same stardust, governed by the same gentle laws. And for tonight, your journey is over. You are home. You are safe. You can rest. Sleep well, and may your dreams be filled with a gentle, silent music. Good night.